Let's first examine table functions in this video before delving further into additional advanced tax calculations. What I mean by that, then, is if I make reference to measures that we have thus far developed, such as the cumulative sales. What we did was utilize all selected as one of the functions in this particular circumstance. When we carried out tasks like the sales ranking, the same was true. The all function and these functions are so-called table functions, as can be seen if I navigate to the sales ranking page. They are referred to as table functions because they return a complete table rather than a single value like a measure. Let's visualize that in practice. I want to demonstrate two functions for you, more especially the all function, which is really three functions. The all function, filter function, and values function because, as we've seen here, they're frequently employed as table modifiers in tax calculations. The all that we have and the filter that was really used. For example, since the second argument in calculate, this one here in our case is always returning a table, we utilize the filter function and all these functions return tables for this running total sales right. Let's investigate those functions in more detail. Therefore, what we can do is make them. Therefore, the new measure here is next to the under modeling there. You may also view the new table here. To create a new table, you can write a tax expression. Here, this is what we do. This way, much like the measures table here, the dates table, and so on, this table will likewise appear here in the fields list. As a result, we must create a complete table rather than just a single measure, which is represented by the little calculator icon. Let's do that, then. Let me go to this new table right here. You can see that it looks somewhat similar to a measure, but it is actually a table. It's no longer specified measure or as the default syntax in this place. Let's imagine that for this table, we'd like to create the orders TBL copy in the manner mentioned above, and that was equal to, well, let's call it by the name maybe, orders TBL all equal. And as of right now, we're just referring to the all function. Let's give it a complete table since we can now offer it a table name or a column name. Say orders TBL and let's close this and then observe what happens. If I press enter, I'll notice that I've now created basically orders table all, and you can see that it perfectly matches our orders table in terms of the columns. Therefore, this is essentially a complete copy of the orders table. Utilizing the old function, we can also look at that by selecting click on data and then select in the data view. To make it easier to see, let's actually shrink the measures table, then let's actually go to the orders table all and select it. And as you can see, that is how the table appears, hence, this is the table that was produced using this entire function. That's also visible from up here. The complete orders table is essentially everything that is there. That is all it accomplishes. This is the traditional function. Simply said, this is only a visual way to analyze or to understand what actually happens if you use the all function in our measures when we build them. Therefore, all just returns a full table without any filters. Let's investigate another table function now. If I return to the report, let's go to the modeling section, select a new table, and perhaps use the filter option. Consequently, if I take on new table here, I'm going to say let's filter it, or let's call it maybe the same way, let's call that ordered TBL. So order TBL, and now filtered. Filtered is equal to, and as you can see, this always provides a hint, so we can now use the filter function in this situation. It returns a table as a result. You could not just create a measure and base this measure on the filter function. Because the filter itself returns a table, that won't work. However, we can create an undo table by selecting New Table, then use the filter function and only the filter function as a criteria. This implies that I could say I want to add a table if I type in filter here. Take the orders table for now. In other words, orders TBL, and then we can give it a filter expression, and let's say as a filter expression here we would want to really be direct and say we would like to say order table, and the order here, let's say the order category is equal to, and then we specify drinks. We then close parenthesis and hardcode the method in that manner. The result of this is essentially a filter table of the order table that only contains the rows referring to the category drinks. We can see that the table gets created in the background if I press enter and we create the table. There it is, we have it in front of us and can examine it. If I select this table here, it will actually shrink as opposed to using the order table all. If I select the orders table filtered, we can select this now and see how it appears. It will actually look somewhat similar to the orders table because the columns and everything else are identical. We now have significantly fewer rows, which is the only difference, as you can see if I scroll to the right. There is only the category drinks listed here under the category. As a result, you can only see drinks if you filter. The filter function essentially offers us the complete orders table that has been filtered by a criteria. In our example, we simply specified that we only want to view the category drinks. As a result, all the rows with other categories were filtered out. That is how it functions. In other words, it's a visual way to see what this table actually looks like when you use it, for example, as a modifier in the cat_late function. Finally, let's actually dive in and investigate the values function, since function is also highly useful and frequently used, and we will also utilize this in the future. Let's investigate this as well, then. In this case, I would choose the new table if I went to modeling and then to new table again. Then, let's say, I'm only referring to my order TBL and now values is equal to here. The values function is now being used, and here, when a column name is given, it returns a single column table of unique values. The statement when a table is given, it returns a table with the same columns. The table itself is therefore not that fascinating for this reason. But with regard to the column, it's intriguing because, if we say we'd like to have the values and then go to our orders table, order table, and select the category, what we now get with these values function is a unique list of categories. Let me press enter for the values here so I can display it to you. You will see that we have created a new table in this area. If I look at it in this values table and select it, though, as you can see, this section contains a small table with a distinct list of categories from this table. As a result, when we look at the orders table here, instead of returning the complete category column, we return this one instead, since it contains a lot of duplication inside and there are a lot of sales for different categories. This is because there are only 8 categories in total. A unique list of this specific column is what we receive. We may use this within the modifying context in the calculate function as well as what the values function can do for us. The introduction to table functions was therefore brief. Other table functions are also available in Power BI Index. But values in the all functions are frequently utilized in the filter functions as well, which is why I want to demonstrate it to you. What this actually accomplishes, how it appears, and the fact that you can use it to create under modeling a table are all described. Additionally, imagine those as fundamental tables. That's it, then. So, as we wrap up this final video, we want to leave you with a message: keep spreading positivity, chasing your dreams, and embracing the beauty of life. Together, we can make the world a better place. See you in another video. Love and peace.